So hey guys, welcome back to my channel, and today we will be discussing another question from GATE 2025 CS1 paper. And the question says that in optimal page replacement algorithm, information about all future page references is available to the operating system. A modification of the optimal page replacement algorithm is as follows. The OS correctly predicts only up to the next 4 page references, including the current page, at the time of allocating a frame to a page. A process accesses the pages in the following order of page numbers. This is the order that is being given to us for solving the question. If the system has 3 memory frames that are initially empty, the number of page faults that will occur during the execution of the process, we have to tell the number of page faults. Just for a quick revision, optimal page replacement algorithm is like when your RAM is full and you want to access a page that is not there in your RAM, you go looking for that page and you find that page. But now the question is, with which page do you need to replace it with? So you replace it with a page which happens to get access the most late in the future, since you have access to all future page references. So this is the optimal page replacement algorithm. But now this is a modification of this. We have only next 4 page references, and now we have to solve this question telling the number of page faults that will happen. So when we have 1 in the beginning and we need to access it, we don't have anything in our RAM, since our RAM has 3 memory frames that are empty. So initially they are empty. Then we have 1. Then we get 1 in one of the memory frames and we get 1 page fault. Now we have to access 3. We get to access 3 and we get 3 in another. We get 3 in another memory frame. Then we have to access 2. We get 2 in another memory frame, giving 1 more page fault. Now the story gets interesting when we have to access 4, because when we try to access 4, we need to replace it with something that is accessed the most late in the future. Since we have access to the next 4 pages, including the 4, we see 1 will be accessed the most late. We replace it with 1 and we get 4, 3 and 2, giving us 1 more page fault. Now we have to replace 2. Now we have to access 2. So we see that it is there already in the RAM, so we don't need to do any page fault sort of a thing. Then we have 3. We see that is also there in the RAM, so no need for some replacement. Then we access 1. Now we see that is not there in the RAM and we have to access it. We need to replace it with something that will be used the most late in the future. Now we see 3 will be the page that will be used the most late. So we now replace it with 3. We thereby get 4, 1, 2 in our RAM and 1 more page fault. Now when we are at 2, we see that is already there in RAM, so no need for anything. Then we access 4. Again, no need for any swap or page replacement. Then we get to 3. Now when we get to 3, we see that it is not there in the RAM and we need to replace it with something that is optimal. So we see 1 and 4 will be accessed in the recent future and we replace the 3 with 2, thereby giving us 4, 1, 3 in the RAM in the end, and we get 1 more page fault. And following this, we have to access 1 and 4, which are already there in the RAM, and so we don't need to do any swaps or page replacements. And then we have a total of 1, 2, 3, 4, 5 and 6 page faults, giving us the answer 6. I hope you understood this question pretty well. If you have any doubts or concerns, please mention that in the comment section. If you liked the video, please share it with your friends who are preparing for the GATE. And if you found the content which I shared in this video something valuable, do subscribe to this channel, hit the bell icon for more such updates. Thanks for watching this video.